So this lesson in Foundations of Math 10 here today is factoring by decomposition. This is a continuation of 3.6 in your textbook. And we just got finished talking about factoring by intuition, right? And that's basically a guess and check method. Now, when we have trinomials that have prime numbers as the leading coefficient here, this number here at the front, and the constant here, then it's pretty easy to do intuition. But what happens if you have, polynomials or trinomials that you think maybe going to take you a while to trial and error to guess and check? Well, there is a more methodical sort of step-by-step way of doing this. And like I say, in the past, some students have really, really liked this as opposed to the intuition because they don't like doing mental math, or they can't really rely on their mental math, or it takes too long. This is just a little bit more step-by-step for those of you that want it. So this is called factoring by decomposition. To introduce this method, I want you to think about what is decomposition. Okay? When you think about decompose, we're thinking about breaking down, right? Decomposition is the breakdown into smaller bits. Okay? So if you think about, a dead animal or something, that's kind of gross, but you think about a dead animal that's decomposing, or, fruit or vegetables that are rotten. They're decomposing, right? They're breaking down into kind of smaller, more simple substances. And so that's what we think about when we do this method, and that's what happens in this method. Okay? We focus on decomposing the middle term. So what are we decomposing? What are we breaking down? We're decomposing the middle term. That's the middle term, bx, right here. So that is the whole focus of this. We are decomposing this. That's kind of the first major part. All right, so this method that we use, it utilizes the distributive property of multiplication. And of course, when you talk about distributive property, you know what that's all about. If we have 5 times x plus 3, and you distribute this by multiplying this term by each of the terms that are in the brackets. And so that's 5x plus 15, right? So that's the distributive property right here. The process of expansion uses this distributive property. When we multiply binomial terms, there's a point in the process where we get 4 terms. So think about when we're expanding. If you have 2x plus 1 and you multiply by x minus 3, when you do your FOIL method, first, outsides, insides, last. That's 4 separate multiplications. And at some point, you're going to end up with, or you're going to get 4 terms. 4 terms. If we group these terms, okay, you group these terms with like the first 2 terms and the last 2 terms, if you group them together, you can take out a greatest common factor between each of these groups. So you take out a GCF, and in this case, between 2x squared and 6x, the factor that's common would be a 2. You could divide evenly a 2 out of here. And you could also take at least one x out, so 2x. And you write this in factored form, see? You take out a 2x, you get x minus 3. You can do the same thing with the second group of terms, x minus 3. Now, it doesn't appear that there's any common factor there, so you would pull out a 1 in that case. And that's what you do. Pull out the greatest common factor of 1, and whatever's left is x minus 3. So when you do this, when you factor by grouping, you take out a common factor, what you should see, what you should get in this method is the fact that we have a common factor, and that's the x minus 3. It's going to be a binomial. Okay? So x minus 3 is a common factor, and you have now this look right here, and you see the 2 factors here? This is sort of a factor and another factor, and this is a factor and another factor. So x minus 3 is common. It's the greatest common factor. So we're going to pull x minus 3 out from these terms. We're going to factor that out. And what you get is you get a common factor, that's this binomial, x plus 3. And what are you left with? You're left with, when you take this out, you're left with 2x. And when you take this out as a factor, you're left with plus 1. So this is the greatest common factor right here. And this is what's left over. Now, after you've done that, and this is just a little part of the process, what you'd notice is that we have the factored form of the trinomial. Now, in this case, I didn't give you the trinomial to begin with, but you can see that this is a factored form. It's a binomial times a binomial. So when we're factoring using the decomposition method, the trick is to get to that step where we have 4 terms from the original 3 terms. And this is where we decompose or break down the middle term into 2 terms. So the middle term, the one middle term becomes 2 terms. So each the 3 terms becomes 4. All right? So as we move through this, let's do an example here. Here's our original trinomial. Okay? And we look at the middle term and we see that negative 5x is our middle term. Right? And so we need to decide how we're going to decompose that. We need to break that middle term into 2 separate terms so that we can factor by grouping. So how do we do that? Well, this is how we do that. You take a look at this number, which is a, right? Ax squared. So a equals 2. And you take a look at the c value here, which is the constant, and c equals negative 3. And what you do is you multiply a and c terms to get this product right here, minus 6. So the first step is multiplying a and c, so you go 2 times negative 3, to get negative 6. Okay, that is step 1, right here. What you want to do next is similar to what we did with when we first started learning how to factor, is you want to list the factors of negative 6. So number 2, step 2 here, if you will, would be to list the factors of negative 6. And I've listed them all below here. Now, what you want to do is you want to check each of these factor pairs, and then you choose a factor pair that adds up to the middle term. So similar to what we did before, one of these factor pairs is going to add up to the middle term. So here's step 3. Choose a factor pair that adds up to the middle term. Now, what was our middle term? Well, our middle term was negative 5. So you look at the list and you say, okay, which one adds up to negative 5? Oh yeah, right here. 1 and negative 6. See that? Alright, so the factor pair that adds up to negative 5 is going to be this one right here, 1 and negative 6, right? So that's step 3, negative 6 and 1. Okay, so instead of just writing negative 6 and positive 1 inside your binomial factors and being done, this is where it gets a little bit different. This is how you decompose your middle term. So these factors right here, that's how we will decompose the middle term. And what I mean by that is this. The middle term is negative 5x. So we actually write that as negative 6x plus x. This is the most important part of your decomposition. Choosing how to decompose the middle term. Because negative 5x could be a combination of a lot of things, right? But we're going to write it as negative 6x plus x. And what that's going to do is that's going to bring us to the 4-term stage that we want to be at. So this will give us the group of terms we can factor for this method. Okay? That gets you to your 4 terms. Once you get to this 4-term method, just like the first example that I did, you now want to factor by grouping. So I'll just hesitate at this stage for a little bit. You want to factor by grouping. So this 4-term polynomial that we've created, right? We've decomposed the middle term and made it into those 2 terms. If we group the first 2 terms, like I have here, and the second 2 terms together, we can now look at those sets and take out a common factor. So you're factoring those 2 binomials. A common factor here, as we said earlier, is 2x. When you divide that common factor out, you get x minus 3. And a common factor here, there is no common factor that you can see, but there always is a factor between any terms. You can always take out a 1. And here is when you do want to take out the 1. Alright? So you take out a 1 and you're left with, again, another factor of x minus. If there appears to be no common factor right here, you still can take out a 1. Alright, so when you get to this point, x minus 3 is your common factor. And then what you do is you take out the common factor of x minus 3. You remove it from those two terms. So x minus 3 is your factor out front, and what's left over is 2x plus 1, and you write that as your second binomial. Alright, and that is your answer now. Now, I did this with a simple example, right? I did this with a simple example so that you could kind of see the process of decomposition. I'm going to now do some examples, and I'm going to go through this process again, but this is your factored version. So here's an example that you can see. Decomposition might be a really good method to use because 6 has multiple factor pairs, and so does 14. So again, your trial and error could get pretty long if we have, the more factor pairs we have for these terms, your trial and error could start to get lengthy. So decomposition is a good option. Alright, so the first thing we're going to do, step 1, was to multiply 6 and negative 14. Alright, so 6 times negative 14 is negative 84. So let's just write that down over here, negative 84. We're going to write a list of factors here. For negative 84, obviously we've got 1 and negative 84, negative 1 and positive 84. We've got negative 2 and 42. And, whoops, sorry, did that again. And also the negative, positive versions of those. So 84 also divides by 4, and that's 21. Right? Now, you can stop at any point where you have a factor pair that looks like it's going to work to decompose the middle term. So, can I stop now? Or do I have to keep going? You can stop now. Why can you stop? Well, because I see here that, remember, I'm trying to decompose the middle term, and the two terms that I choose to replace that one term has to come from a factor pair of negative 84. So, what about something like this? 21 minus 4. Doesn't that give you 17? Right? So this is what you're going to do. You're going to now rewrite this middle term right here as, and it doesn't matter which one you write first, doesn't matter, negative 4x plus 21x. The decomposition method hinges upon the fact that we need to decompose this middle term. Does everyone see what I've done? Everyone see that? Okay, that's crucial right there. To choose the factor pairs that match here. Yeah, these are factors, so they are multiplied to get to negative 84. But what we're doing is we're showing those factors as a sum of terms to make this one. Yeah. So we're not multiplying, we're actually combining them. Okay? Alright, so let us factor, let's go back to blue. Let us group, or factor by grouping. So I'm going to do this, and I'm also going to do this. And yes, I would suggest you put the brackets on there. Just throw your brackets on so that you can focus on the two terms at a time. And we'll take out a common factor here. So what's the common factor between 6x squared and negative 4x? Well, not 4x, no, because 6 doesn't divide evenly by 4. So you can't take out 4, but you can take out 2, yeah. And you can't take out x squared because this one doesn't have x squared in it, so you can just take out 2x. What are you left with then? Well, we're left with 3x minus 2. Everyone see that? You factor that 3x minus 2. So we're going to do the same thing over here to these pair of factors. I'm sorry, just these pair of terms here. A common factor that we could take out would be what? 7. Okay, let's say plus 7. What am I left with here? 3x minus 2. Very good. So this is super important at this stage right here, okay? What's really important here is that you have a common factor binomial. That is really important. If these two are not identical, you have to go back and either double check to make sure that you've got the right pair, or you have to make sure that you have pulled out the correct factor. So for example, let me just show you. We did this correct. But let's just say that in this very last stage here, let's say I pulled out a negative 7. Because you could, that's a factor too. If I pulled out a negative 7, I would have left over negative 3x plus 2. So if you did that, and at this stage you say, hey, these are pretty close, but they're not identical, you have to stop and you have to say, okay, I need to look at maybe a different factor to pull out. And that's where you would go back and you would say, yeah, let's do the positive 7 and see what I come up with. And that's where you get this. So when we have this common factor, now we can remove it. So we write 3x minus 2 as the common factor. What's left over? Well, we have 2x left over. So that's 2x there. And we also have plus 7. So we'll write that as well. And there you have, that is your factored version. You're done. The 2x, okay, so here's my common factor, right? Yeah. I removed it. I divided it out of this term. So what's left? 2x. Oh. So if I take the common factor out here, 2x remains. So you write this as multiplication. There's your GCF right here. 2x. Oh. And if you take the common factor as well out of this term, this gone now, look what I'm left with. Plus 7. You just write plus 7. Okay? Now this is a bit more of a methodical method. Like I say, if you have some easy trinomials with prime factors here and here, you don't have to do this. You can just go. But for many trinomials where you have many factor pairs, like I say, this is a pretty good one to use. So we'll do a couple more examples here. Okay, so here's example 2. Now, you look at these numbers and you think, wow, these are pretty big numbers. I definitely want to use decomposition. Please don't forget, and I will just remind you of this once in a while, please don't forget that when you first start to factor, if you have a common factor that you can pull out immediately at the beginning, you need to do that. You're not going to get the wrong answer, but it will save you a little bit of mental energy down the road. Okay, you'll work with smaller numbers. So what I'm saying is that if you look at these 3 terms here, do you see that there's a common factor of 2 you can remove first of all? So let's do that, and it'll make this a little bit easier. So we write this as a common factor of 2. I'm going to pull that out from all of these 3 terms. And I'm going to be left with 12v squared minus v minus 35, right? So if you have a common factor, especially a number, that's a common factor, but any common factor that you can remove at the very beginning of the question, please do that. And most students, or actually a lot of students, forget about this too, that this 2 has to remain in the question for the rest of the question, because it's a factor, so it's not like it's gone. You can't just say, okay, 2, get out of here, I'm just going to focus on the rest of it. You have to leave it there. So, in that case, if we're going to use decomposition for this one, let's find out what A times C is. So 12 times negative 35 equals 420. So that's negative 420. Okay. Well, 420, okay. Now you may be thinking to yourself, there's a lot of factors of 420. And yes, there are. But if you realize that the 2 factors have to add up to negative 1, that means that the 2 factors are going to be really close to one another, right? They're only going to be one number difference. So you don't have to consider 1 and 420, 2 and 210, right? You don't have to consider those. You can be smart about it and start to list factors that are pretty close to being, closer to one another. So let's take a look at those factors. Let's divide 420 by 20. What do we get? Oh goodness, look at this. That was a good guess. Look at 20 and 21 are only one number apart. So guess what? We're either going to use 20 and negative 21 or negative 20 and positive 21. You see, you don't have to list all the factors either. You can kind of use your brain. Which factor pair are we going to use to decompose this middle term? Which one is it? Positive 20 and negative 21 or negative 20 and positive 21? Because this is a negative, you're going to want to use this one. So, you rewrite the middle term, you leave everything else the same. This middle term becomes plus 20v minus 21v. You see? You see? VV. So now we're going to factor by grouping. Let's do the first two terms, the last two terms. Let's factor by grouping. Make sure this 2 remains out there. Okay, so what's the common factor between 12 and 20? Okay, you can take out 2. Can you take out a larger number? 4. Yeah, and there's a v in each one, right? So let's take out 4v. What are you left with? 3v, because that multiplies the 12v squared. And then 20v divided by 4v is 5. So we've taken out a common factor of 4v, and I've written what's left over as this binomial here. Do the same thing to this pair. Now both of them are negative, so guess what? You're probably going to want to take out a negative common factor. And what's a number that divides evenly into 21 and 35? It's going to be 7. So let's take out a minus 7. What are we left with here? 3v plus 5. Okay, let's take a look at that. Does that make sense? Make sense? Yes? Alright, so our last step here is to look at this. Do we have the same factor here? Yes, those are identical. So let's pull this out and pull this out as a common factor. So I have 2 as a factor. Good. I now have 3v plus 5 as a factor right here that I've pulled out. And what's left over? 4v minus 7. And there you should be done. I'm going to do a quick check. I'll show you a quick check here just to make sure we've done this correctly. So when you're factoring this, remember we're trying to get down into simplest prime factors really. And so yeah, you wouldn't multiply the 2 in, okay? You'd leave it out as a factor because this is fully factored. Yeah, just leave that 2 out. That's why we take it out early too, because Anyway, so let's do a quick check. So in our check, of course, you want to multiply the first 2 together first to get 6v plus 10. And then we're going to multiply that by the third factor here. And so we do FOIL method there. 6v times 4v is 24v squared. 6v times negative 7 would be negative 42v. And 10 times 4 is plus 40v minus 70. And so, wait, 6, 7, 10, 4, did I do everything right here? 24v squared, what's negative 42 plus 40? Minus 2v minus 70. Yeah, the negatives there. All right, and so this is what we have when we, now is this the same as the original polynomial, the original trinomial? Let's back up there, yes, it's identical. So there's your check, and you've done it correctly. So this is your answer right here. So take a few minutes and do this question on your own using the same the decomposition method, following your rules. See if you can do that. If there's any common factors, pull that out first, and yeah, just go ahead and see how you do with this one. All right, so if we walk through this answer here, the first thing you should notice is that you can pull out a common factor of 5 between these three terms, right? So you pull out that 5 right away. What you're left with is this trinomial. Now, this is prime and this is not prime, but there's not a lot of factors. So by intuition, if you had the choice, you might go straight to intuition. But maybe now some of you are particularly enjoying this decomposition method. Maybe you want to use decomp most of the time. Well, we have to multiply 3 times 4 to get a times c is 12 over here. And remember, you want factors of 12 that add up to negative 13. So I saw some of you kind of forgot about these negative signs here. But yeah, negative 12 times negative 1 is positive 12, and this is the pair you're going to want to use. So I wrote my factor pair right here, negative 12a minus a. If you wrote this in the other order, if you wrote your negative a first and your negative 12a second, then this step of yours will look a little different than mine, but you should still get the same answer. So this is the way I did it. I grouped these two terms together, pulled out a 3a, got this as a what's left over, pulled out a negative 1, got this, these are the same. Pull out this as a common factor now, that's why I wrote it there. What's left over? 3a minus 1. Okay, so that's how you do the decomposition method. Feel free to do more examples. I'll give you your assignment in a second.